Hello everyone, welcome to this tutorial of the D3A. Let's start here on the home page. So you go to d3a.io and you'll see where you can register for a new account. As you register, you'll click next and it will take us about 1 to 2 days to approve your registration. On the home page, we've recently added our videos from Event Horizon, so you can take a look at the introduction video and deep dive that we presented. And you'll see at the bottom of the screen here, we have a link to our GitHub where our backend code is released under GPL3 license. So you can check out our code base there. You can also click to our wiki, and this will give you all of our documentation so far. And so it's broken into the user interface and the backend code base. So if you need any help navigating the UI, you can go here and click on these links to get more of a background and maybe answer some of your questions. Lastly, we have our Gitter community, and if you go here, you'll see a community that we started with a couple different users, and you can just type your questions to us here. We'll get back to you as soon as possible. So to log in, I'll just log into my account, and then I'll land on the home page. So on the home page, I have my user here where I can log out, and then I have a list of all of the projects I'm working on. And as you can see here, we have some projects have this symbol, which means they're a public project. So that means that as Grid Singularity, we've created these projects and opened them for the public to look at. So these two projects everyone will have in their homepage when they log in, and then these other projects are ones that I have built. So scrolling down, you'll see at the bottom of the page, you can also go to our links here if you need to read some more, ask us a question while you're working. And then our projects are set up. I'll create a new project here, and then you can add a description. And our projects are set up so that you can build simulations inside a project. So the idea is if you have one project and it's for a specific use case, so maybe you want to call it Berlin microgrid, for example, then you can start to put your simulations inside your project, and you can create different versions. So let me show this actually. We'll call this project Berlin microgrid, and I can start creating different simulations inside this project. So for example, I'll start a simulation and I'll call it Berlin microgrid version 1. And then I can go ahead and start making one of my simulations. So to make a simulation, I can set the length of the simulation, which we'll be adding a feature soon, so you could run it for more than 1 day. And then we have the description box. This simulation can live inside the Berlin microgrid project, or I can move it to any of the other projects that are available on my homepage. And then I can also choose the global solar profile for the community. So here I can choose sunny, partially cloudy, cloudy, or upload my own profile. And we have this set so, for a specific microgrid, you might have one solar profile for the whole neighborhood because it's getting more or less the same weather. So you can set this here, and then as you build your grid, you can set individual profiles for different homes or different communities if you actually have, different solar information for different homes, for example. Then when you look into the advanced settings, you can start the date of the simulation, and this is more in line with the profiles that you're using. So if you upload a profile with more than 1 day in it, you can change the start date. The default is today's date. And then we have some information about the types of markets available. So in this D3A, you can configure different spot market types. So we can configure here one spot market into the future, and the length of the spot market is 15 minutes. And the tick length is 15 seconds. So these parameters will be configurable soon, but how we have it set as a default is usually these devices trade in 15-minute market slots. And they usually trade one market in advance, which is this number. But if you wanted to create, say, 4 market slots in advance, which would be 1 hour in advance, you could have devices trading for the next 15 minutes, also for the next 30 minutes, that 15-minute slot, 45 to 1 hour. And then we have some information about the market maker rate. And so this is usually the cost of energy from the local utility or local market maker. So if you're building a community microgrid, in Germany, we set the default to 30 cents per kilowatt hour because this is the cost per kilowatt hour of electricity here. So you would want to set this depending on your location of what the cost of electricity is, because the different agents that will be selling power in the simulation will start selling at this value, and then they will decrease what they're selling at. So this helps create a microgrid that is selling in competition or at the market rate or lower, so that your customers will save money. So that's something to take into account. And then when you start building your simulation, you start with this blank slate, and you can add 2 different types of devices. So you can add areas, and then you can also add devices. So for the D3A, an area means a market. So there's a spot market for every area that you configure. And then inside the area, you can put as many devices as you want or other areas. So I'll call this Berlin. And then inside Berlin, I can immediately add all of these other devices. So I'll add another area that's called Neukölln, where our office is located. And then below, I'll add another area for GSY office. It's here. And inside these areas, I can also start to add devices. So all of these purple diamonds are different devices that can consume or produce energy, or both, and those can be added to these different areas. So the devices that I add here, they will trade with each other inside the Grid Singularity office market, and then any power that is not able to be consumed or produced, those offers will be forwarded into the upper markets. So that way, if I have a device in the Neukölln market, maybe on a different branch here, it can trade with one of the devices in the GSY office market. So we have this hierarchical structure set up in order to incentivize local trading. And depending on how you picture your grid and maybe the ownership of these different areas, you want to think about how to group these devices. So for this example, I'll show you, we'll group devices inside the office. There might be devices inside someone's home. So this is kind of the standard of how we develop these different areas. And then these different areas can be grouped under one bigger area, like Neukölln, for example, if that's the entire microgrid, and then connecting to Berlin. So here I'll add a PV. And so for all of these devices, you can increase the number of PVs. So that would mean more than one PV installation. And you can also increase the number of panels. So if you have a specific profile here and you want to double the profile, you can add more panels. We'll also have some information about the strategy of the PV, and I won't get into that so much today, but it's detailed in our wiki, and we'll be adding a user guide to the UI, so you'll be able to hover here and then maybe click the link directly that goes into how the strategy works. But the default strategy should work fine, so I'll click Save, and then I'll add a load to the office, and that wasn't a load. Here we go. And I can call this office load 1, for example, and I could upload a profile here, or if I just know some details about the load, like the average power, how long it's on per day, what are the hours of the day, then I can also put in that information. So I'll save that. You can also add an energy storage. And so for the storage, we have the total capacity of the battery, and then you can configure the initial capacity or the initial state of charge. So the initial state of charge is 10, we could change it to 20, and then what's the maximum power rating for the battery, and then how will it sell its energy, what is its strategy here. And so for here, there's also a link to this on the wiki. You can read about the storage strategy. But in short, it has a break-even buy or sell price. So all the devices that are trying to sell energy, they will start selling usually around the market maker rate of 30 cents, although you can configure that. So they'll compete with the market maker, and then as there become more or less buyers on the market, they will decrease their price. In the storage, for example, it sets up a break-even buy and sell. So if the prices, if it will try to start selling at the higher price, the market maker price, and if no one buys its energy at this price, then it will start to decrease its price. But at one point, at the break-even point, once the market prices get so low, the energy storage will, instead of trying to sell, it switches and it tries to buy power from a PV that's selling at a very low price, for example. Okay, so we'll save this energy storage, and then, yeah, let's add some flats in the community. So add here, and here we can add homes, for example. And so I can make this 5 homes, and let's upload a profile. I'll just show you how that works. So I have this list of profiles here, so we can just upload profile 22. So these homes all have the same profile. Save here, and let's add some production. So inside the Berlin microgrid, there would be a power plant. So we have an infinite power plant, which is like an infinite bus. So it can produce a limitless amount of energy. So I'll add this, or you can also add a finite power plant, and you can say, what is the maximum power available for that plant. So I'll just delete here. And then let's add maybe a community PV. And we'll make this much bigger. Great. So you can see how you can set up your grid. And Neukölln is one neighborhood here, but I could add another neighborhood called Mitte if I want and start building that out. And the way we think about this usually is we look at this use case called community as a service. And you can watch some of the videos from Event Horizon about that. But community service looks at enabling a community to trade with each other in a way that benefits the utility or DSO. So that's one use case we focused a lot on, and in that case, if you're building something similar, you want to configure all the homes or different smaller microgrids in your community, and then have a point where they're connected to the main grid. And then you could look at, what is the total energy that is going into the grid and coming out of the grid. And then you can also look at, what are the energy bills for your community, and how will this evolve over time in order to prove whether this is a good business use case. So I'll go ahead and run the simulation. And you can see here on the results page, we have a breadcrumb on the side, and it looks into all of the different devices and areas that we created in the grid. So it's really great because you can click on every single area, which is a market, and see what the results are inside that market. And you can also click on each individual device or agent and see how that device participated in the markets it was involved in. So to give you a quick overview of the results page, the first graph is the energy availability. And so this graph, there's a green indicator here that tells you that all of the loads that wanted to consume inside this market, which is inside the entire grid, were able to during this time. And if the marker is purple, you'll see a drop down of the different times that a load was not able to consume. So in that case, if one of these was purple, we could see which device that was and then go into the deeper device to see exactly how it was impacted. So this type of graph is really useful for energy access use cases. So those are cases where you have an isolated microgrid that's not connected to the main grid. So in that case, you might have a limited energy supply, and you would have loads that maybe were not able to buy power. And that would be something that you would look at. But in our case, we had an infinite power plant, so there wasn't any case where power wasn't available. Looking into the cumulative trading, you can see here what the flow of energy was inside the Berlin market. So this is set up, so for the two different entities inside the Berlin market there, Neukölln, which is an area, and then also the infinite power plant. So the negative values here are production. So Neukölln is producing a certain amount of energy, and it's green here. So then we can see where the top value is green is where that energy was purchased. So Neukölln basically purchased all of the energy that it produced, and then it purchased this additional amount of energy from the infinite power plant. So the infinite power plant is producing purple, and Neukölln is producing green here. Scrolling down, we can take a look at the energy bills inside the Berlin market. So we can see Neukölln, what was the total energy that it purchased and what was the cost, and then what was the total energy it sold outside of its area and what was the revenue. So here it consumed everything inside, and it bought 18 kilowatt hours from the infinite power plant, which is shown here. And then when we look at the total costs, these negative values mean that there was a negative cost. So the infinite power plant made, it sold this much energy, and it made €6 profit. And then the accumulated trades is a sum of all of the trades happening inside a market area. So their total should be 0 here. Next, we have an energy trade profile inside the market. And this graph is very similar to the cumulative trading, but it allows the user to see exactly how much energy was traded during each 15-minute market slot. So looking here, again, the negative energy is sold energy, and the positive energy is bought energy. So the infinite power plant was selling all of the energy, and it was purchased by Neukölln. And this graph should always be symmetrical because we always have an energy balance. So every time energy is purchased, it comes from a seller, and that seller is represented here. And we're in the process of adding scroll bars to our different graphs. So you'll actually be able to zoom in and look at different parts of a day, or if you're running a simulation for more than one day, you'll be able to look at, you can zoom in to one day at a time. Yeah, it won't show up here, but if I click on the infinite power plant, my results will be filtered so that I'm only seeing who the infinite power plant sold power to. But we'll be able to look at that on a different graph. And then lastly, we have a graph about what was the energy pricing inside the market. And in this version of D3A.io, we only have the one-sided pay-as-offer market. We are adding our other market types, and they will be available very soon. But in the one-sided market, the offers are making an offer at a specific price, and then the devices that are consuming are just buying the cheapest offer. So we'll be able to see how the price fluctuates depending on if a selling device had to lower its price in order to get a load or a consuming device to buy. So we can see if there's any difference in the average price, if there's also lower or higher prices during a specific energy slot. So next, let's look through the breadcrumb. And here, I can click on the market Neukölln, which is another area, and I see the two areas inside it, which is the GSY office and flats. And here, you can see kind of more of what this graph is capable of in the cumulative trading. So here we have external trades. The community PV is producing this purple power. The flats are not producing any power, so they have no negative here. And then the GSY office is producing green. So we could see wherever there's green in the positive, that's where the energy was bought from the GSY office. So the GSY office consumed some of its own power, and then it sold some to the flats here. And also with the community PV, it produced this power. It sold some to the flats, which is this purple bar, and some to the GSY office. And the external trades represent trades that are happening outside the Neukölln area. So in this case, there was some energy imported externally. So the external trades have negative energy here, and it says external sources sold 18.6 kilowatt hours. And we can see, because this is dark blue, that this energy was sold to the flats. And it's possible as well, if there was a really big community PV here, and if there were loads externally outside the Neukölln market, the PV could potentially sell power to external sources, and then we would see a purple bar here. So going into the energy bills, fairly similar to before, but we can see the different market participants here. There's more market participants in this market. And then looking at the energy trade profile graph, we can actually filter some things. So if I click on community PV, for example, it zooms in so that I can see this green here is the production of the community PV, and I can see exactly who it sold to. So earlier in the morning, it sold most of its power to the flats. In the middle of the day, most of the energy went to the GSY office, and then at the end of the day, most of the energy went to the flats. So now I think you have a good idea of the graphs for the different areas and markets. Now let's look at specific devices. So inside the GSY office, if we click on PV, we have these specific device results for the PV. So the first graph shows what was the actual PV profile. And you can think of this as the forecast of expected PV production. And so based off this forecast, the trades were scheduled. So the PV wants to schedule a trade in order to sell all of the energy in its forecast. So here's the profile, and then in the energy sold, there's actually two bars that are overlapped here. And so one is the PV profile and one is the energy sold. And optimally, you want to see that both bars are the same so that the PV was able to sell all of the energy in its profile. And then at the bottom, you can see the energy price. And so this is a graph that shows how much the PV sold its power for. And so in a time slot like 15:15 here, you can see that the PV sold power at two different prices. So it sold power to one buyer at 30 cents per kilowatt hour and another buyer at 24 cents per kilowatt hour. So we can see how the pricing varies for a specific device during the day. And at the bottom, we'll get the total energy bill for the PV. So as a PV, it can't buy energy. However, it produced 1.4 kilowatt hours, and it sold that energy for 41 cents. So we can see this in the sold and the totals. So going over to the load, here we can see this is a very simple load. So the profile is basically on or off. So you can see it's on here. And the energy bought and the load profile are plotted on top of each other. So in this case, this load was able to buy exactly according to its profile, which is the desired behavior. So we see no difference. And this load purchased power at 30 cents per kilowatt hour across the time of its buying. And then here we can see the summation of its energy bill for one day. Then lastly, we'll click on the storage, which is a little bit different. So in the storage, we plot the state of charge. And we started at a state of charge of 20%. And then we can see that the storage, it discharged in the beginning of the day to satisfy some of these loads. And then when there was excess PV power, it charged during the day to 84%. And in the energy traded, we can see what the energy was going into the storage. So here, when the storage was discharging, its energy trade is negative, and then the energy trade is positive as the storage is charging. And lastly, we can see the energy price for the storage. And what's interesting here is when the storage is selling power, it's selling at a higher rate at 30 cents. And then when it's actually charging, it's buying mostly at 24 cents. So this is good, and this means that our storage should make a profit. So let's scroll down and see if that was the case. Here we can see the total cost that the storage bought power, and then it sold totals of 1.38 euros. So it made a profit of 40 cents. That's good. And you might wonder, how do I know that the storage is charging from the PV, for example? So in order to zoom in on this, we would click on the GSY office market and then go to look at these graphs here. And we can click on the storage and see exactly who it was selling to or buying from. So the storage here is selling to the GSY office. And then during this part of the day when it's charging, it's actually buying power from the GSY office. So we don't know exactly which device this is. So this means it's coming from outside the GSY office. So it's coming from the community PV production. So here when it says GSY office, that's what we call the inter-area agent, which is bringing bids and offers into and out of this GSY office market. And in this case, the storage is selling, and it's selling outside to externally. And let's scroll up, and we can see here the same idea. So here the storage is blue. So its production would be blue on the positive axis, and most of it's going externally. And then most of what the storage is charging is also coming from an external source. So this is most likely the community PV, which is here. Yeah. So to just as a lastly, we can look at the infinite power plant. And this graph is pretty simple. So we see where the infinite power plant is selling energy and what is the price. So it's selling at a set rate of 30 cents. Great. So yeah, to summarize, from the results page, what you can do is edit your configuration. And then in this case, we could go and add another device here and run the simulation again. So you have this opportunity. Or on the main home page, you can go to your simulation and actually make a second version. So this button duplicates the simulation, so we can make Berlin microgrid version 2. And this simply duplicates the exact same simulation and stores it in the Berlin project. So then we could add another device here, like a storage, for example. So going back to the main page to review, so this button duplicates the simulation. This would delete it. This button goes directly to the results, and this button runs the simulation, and this button edits the simulation. So I would go here if I wanted to add more devices to the simulation. I would go here to run the simulation, and then once the simulation is finished running, the results will be stored. So from the home page, you'll be able to click the results button to just go straight to the results without running the simulation. So let's see if it finishes. And here I can go directly to my results. And if I click here, I would delete the simulation, and here to duplicate the simulation. So one last feature that I wanted to share is you can save different areas or devices inside the library. So right now we have a lot of things inside the library, and these elements inside the library that have this symbol here are the public libraries. So these are libraries that are provided by us to all users. So every user will have these public libraries. And what we started to do is put different load profiles that we found here. and also model different devices. So we have Tesla Powerwall, the Sonnen Battery Eco, and then we have some of these standard load profiles for different load types in Germany. So this is to help users to take different profiles and incorporate them into their simulation. And in the future, users will be able to also provide their own profiles into Community Library. So to show you a little bit how this works, let's go back to our simulation here. And if I wanted to add another device, I could go to the library here and add something from the library. So let's see if we can find, the Sonnen battery. I can also search for this battery. So if I know the name of it, I can just start typing in Sonnen and I can add the device here. And as you can see, there's a little bit of a bug here that we've currently fixed in our dev version. So we'll be pushing the results to here soon. And this is because this one has an uploaded profile. So if I look for, I think I had a whole neighborhood here, Mitte. This one might work. So this is a work in progress, but you can add different devices to your simulation. And then in addition, you can save a device to the library. So if you wanted to save this infinite power plant, you would be able to add it to the library and give it a name. We call it version 1, and then it's added to the library. So if we go to the library view, we can search for infinite power plant, and we can see it here. And then here, you could even edit this and start adding additional stuff to this library to build it up. So this is just something to help users upload maybe their profiles into a library and then take these individual PV or load profiles and put them into their own simulation. Or they can also build up a small grid configuration, save it to the library, and add it to many other simulations. So to sum up, I think that is everything for the first tutorial. Please, let us know what you think, and we'll have more tutorials, maybe a webinar coming soon to kind of walk you through the basics of the D3A and how you can get started. And if you have any questions, please contact us via our Gitter, and that is located here. Great.